Hi, in this lesson I will try to explain what is a function normally written as y is equal to fx. What is a function in the language of mathematics? And secondly, I will explain what is limit of a function. Limit of a function fx as x approaches a value a. What is a function? Function is a word often used not only in mathematics but also in normal English communication. Some quantity y is a function of another quantity x. Simply means that the value of y depends on the value of x, or the value of x determines the value of y. For example, the marks obtained in exams is a function of efforts put in by the student. Simple enough. The more the efforts an student puts in, the more the marks he will get. So marks depends on the efforts. So I can say marks is a function of efforts put in. In language of mathematics, however, the dependency of y on x is very definite, unlike the vague relationship described in this statement. For example, in maths, y is equal to 3x minus 4 is a specific example of a function where once x is defined, y is exactly known. Another example could be y is equal to x square minus 7 or any such examples. In each of these cases, if x is known, the value of y can be exactly determined. In mathematical notation, the statement y is a function of x is written as y is equal to f bracket x. Note, this is a general statement which simply says y is some function of x. This statement does not say what is the exact nature of the functionality. It says y is dependent on x. It doesn't say what will be the value of y once an x is known. However, these are specific examples of function y being dependent on variable x. X is normally referred as the variable of the function y. Next, we come to limit. Limit of a function as variable x approaches a value a. Notice I am not saying x is equal to a, x approaches a. This is best explained through an example. Suppose a stone is dropped from a height at a time t is equal to 0 seconds. It is known that at any time t, the distance travelled is equal to 5t square. What is the average velocity of the stone for the period from 3 seconds, from a point in time at 3 seconds till, let's say, 5 seconds? What was the distance travelled at 3 seconds? 5 into 3 square is equal to 45. 5 into 5 square is equal to 125. The distance travelled is 125 minus 45, which is 80 meters. And the time gap, which we denote using delta t is a notation used for denoting interval of time, difference of time, which in this case is 2 seconds. So 80 by 2 is equal to 40 meters per second. Now this is the average velocity from 3 seconds to 5 seconds. What if I ask you to find the instantaneous velocity at t is equal to 3 seconds? Using the same example, can I say distance traveled from 3 seconds, from t is equal to 3 seconds to t is equal to 3 seconds, distance divided by time gap? Obviously no. Distance traveled from 3 seconds to 3 seconds is going to be 0, and the time gap from 3 seconds to 3 seconds is going to be 0. So 0 by 0, which is not defined, it has no answer. So how do I find the instantaneous velocity at 3 seconds? Well, I could say, okay, 3 seconds, my first instant I take at 3 seconds, and the second instant I take pretty close to 3 seconds, let's say 3.1 seconds. And the distance traveled at 3 seconds is 5t square, 5 9s are 45 meters. The distance traveled at 3.1 seconds, by the same logic, it works out to 48.05 meters. The distance traveled is 3.05 and the time duration is 0.1 second. So this works out to 30.5. This again is the average velocity from 3 seconds to 3.1 seconds. It's not the instantaneous velocity. How do I find out the instantaneous velocity at 3 seconds? Is it even defined? What if I claimed a number? At the moment I'm just saying I claimed it out of my hat. What if I claimed a number? In this case I will claim 30 meters per second, and my claim is that these two instances that you took, 3 seconds and 3.1 seconds, and we calculated the velocity, average velocity between these two instances. I will take two instances, one at 3 seconds, other at 3 plus a small time delta t seconds. I'll find the distance here, I'll find the distance here, I'll subtract the two, and I will find the distance traveled during this period, and I will divide it by the time gap. And this will be close to 30 meters per second. Close is a very, very mathematically incorrect word. There is nothing called close. My claim is I can bring it as close to 30 meters per second as desired by reducing delta t more and more. In other words, if I reduce delta t, the difference between this 30 meters per second, that's my claimed velocity, and the calculated velocity, the difference between these two will reduce. As I reduce this delta t, as I take the second instant closer and closer to the first instant, I cannot make it exactly at 3 seconds, but I can make it closer and closer to the first instant. As I make it closer and closer, the calculated velocity that I will get will come closer and closer to the 30 meters per second. And how close can I bring it to 30 meters per second? Here is the catch. How close can I come to 30 meters per second? There is actually no limit. You want me to choose the second instant such that the calculated velocity comes to 30 meters per second plus 0.1 meters per second. Yes, I can get you that by taking a smaller value of delta t. No, you don't want 0.1 meters per second, you want 0.001 meters per second. Yes, possible. I'll take delta t still smaller. First instant at 3 seconds, second instant at 3 plus something is still smaller, and I will get 0.001 meters per second, within 0.001 meters per second of my claimed velocity. I can bring it as close to my claimed velocity, my claimed number, of 30 meters per second as I want, as close as I want, by reducing the delta t more and more. The more I reduce delta t, the closer it will reach to 30 meters per second. There is no limit to how close I can get to 30 meters per second. If this is what I can prove, then this is called to be limit of delta s, distance traveled, divided by delta t, time gap, as delta t approaches 0. And how did I arrive this 30 meters per second? I will probably explain in the next part of the video. I claim that this is 30 meters per second, and if I can prove that by reducing delta t more and more, I can get the result closer and closer to 30 meters per second, then this 30 meters per second is known to be the limit of this function, delta s by delta t.